Hello, and welcome to the webinar. I am Kevin McGrath, CTO of Spot by NetApp, and today we're going to be going over day 2 Kubernetes. So navigating your path in Kubernetes to scale. We're going to be talking about those key challenges that DevOps teams face when they actually have at-scale applications running in Kubernetes in the cloud. It's a very different problem set that you have to solve for than when you're on day 0 or day 1 setting up a Kubernetes cluster out of the box. What do you do with that cluster once you have mission-critical applications running at scale? We're going to dive into that today. So thanks again, everyone, for joining, and let's get into it. What is day 2, and what does that mean for Kubernetes and what you're doing? So first, a little bit about Spot by NetApp. We lead through what we call Cloud Ops. Cloud Ops is everything that you need to do in the cloud, and that's really built on 3 different pillars. There's DevOps. DevOps is what you do and maintain in the cloud every second, every day, 365 days a year, how you're monitoring every second of that application and keeping it running, how you're deploying that application, how your CI and CD pipelines get there, and then not only get there, how you're optimizing that application once it gets to the cloud. These all fall under that DevOps flow. Now, while your applications are flowing to production and while you're monitoring and constantly releasing, you have to think about how much this is costing. At the end of the day, everyone needs to think about cost. And FinOps is a big pillar here, where you take into account how you're paying the cloud provider. What type of instances are you paying for? What type of commitments do you have? What price models are you using in your favor to make sure that that application that's running in the cloud is as cost efficient as possible? Because if you're successful, eventually you need to scale more. And when you need to scale more, you need to do it with cost in mind. And then finally, there's SecOps, security and compliance. Everything that you do in the cloud, we hear about it all the time. People have misconfigurations or things go astray. You have to have security focused. All of our products from Spot, for instance, all security focused when going to the cloud, and you need to do the same thing with your applications. So if you're taking care of your DevOps, your FinOps, and your SecOps, you're in a really, really good place to run your cloud operations. And that's what we're going to be talking about today, cloud operations of Kubernetes clusters. So we're going to jump right into it. We're going to explain what Kubernetes Day 2 is. We're going to say why Day 2 poses a problem for DevOps and why you should be concerned of this as you're experimenting with Kubernetes, or maybe you're already at Day 2. We're going to talk about maybe some of the pains that you're feeling today. If you're not at Day 2, we're going to talk about some of the pains that you might experience in the future. We're going to go over the 3 key questions that we see out of all of our customers around DevOps in Day 2. And then we're going to go over what it means to have hands-free infrastructure for containers, and then we'll jump into a Q&A. So let's get started. What is Day 2 Kubernetes? So we hear a lot about Day 0, Day 1, and Day 2. So let's put some definition around this, right? You can also look at this as like crawl, walk, run. You can also look at it as an evolution pattern of what we have here. Day 0, you've decided to look at Kubernetes. You've decided to maybe migrate from VMs to containers, or maybe you're at containers, but you never got into a big scheduler like Kubernetes. So you started designing, you started trying to pick what platform you're going to use, maybe what cloud provider you're going to use. Maybe it's EKS, AKS. Maybe you're going to do your own homegrown Kubernetes. You're starting to figure this out with your architecture team and starting to figure out what paradigms, what choices and technology you're going to make. So once you've decided how you're going to run your Kubernetes cluster, that Day 1 is your first configuration in your deploy, right? You've decided how you're going to run it. You're taking that first application, you're shooting it out to the cloud. Maybe you're running your dev and your test environments. Maybe it's even the first production application that you have. The point is that you're still figuring out what Kubernetes means to you and what it means to run in production. When we talk about Day 2, we're talking about full-blown production-grade applications, scaling, availability, performance, cost management. This is mission critical to your business, mission critical to the applications that you deploy, mission critical to your team to keep alive and keep running. This is Day 2. So Day 2 is where we're going to focus today. And we're going to talk about why day 2 is different than day 0 or day 1. So real quick, day 2 is here. You've probably seen these graphs before. These are common adoption graphs going from 2016 all the way through 2020. And the important thing that you can see here is, those lighter colors are the adoptions, about 4 years ago. And then the darker purples are adoptions today. Not only is 92% of containers running, or 92% of containers running in production, it's gone up dramatically over the past 4 years, and it's gone up for every environment. You can see it was very heavy, almost even across the board for proof of concept. A lot of people were doing proof of concepts 4 years ago, but what people weren't doing 4 years ago was running those day 2 operations, those production grade applications in the cloud, and you can see that 23 to 92% jump over there on the right. 70% of users have more than 50 nodes in their cluster, and we consider this a good benchmark for your scale and how you're running. Now, nodes come in all different shapes and sizes, and we realize that, but this is a good benchmark for how large a cluster is. But more than 70% of users we see with more than 50 nodes attached to a single Kubernetes cluster. This speaks to the scale and size Kubernetes clusters are getting to, and the impact that they have on your cloud bill and your production systems. So we talked about it at the top. We've defined day 2. We've talked about how day 2 is here, how a lot of people are running in production today. Applications are relying on Kubernetes. These containers are relying on Kubernetes. So what's the problem? Like, we're here, they're running in production. So what's the problem? So we have four issues laid out here. First, not my problem. And you kind of hear this a lot, the handoff between engineering and DevOps and production. Who's managing that infrastructure behind the Kubernetes cluster? So Kubernetes by default kind of abstracts the infrastructure away. It doesn't matter what cloud provider you have underneath. It can even run on-prem, right? And Kubernetes by default doesn't necessarily orchestrate that underlying infrastructure. You need a cloud provider, or you need a plugin. You have to enable a plugin to actually operate that infrastructure underneath. So who's in charge of the infrastructure? When engineers and developers are freed to deploy containers and not worry about the VMs and the networking and the storage that are underneath, whose job does that become? And where does that come in the responsibility model? Who owns that? Usually it's the DevOps engineers. That's whose problem it becomes. So we're going to go below that. We talked about DevOps. DevOps are outnumbered. If you look at all the common statistics, you're seeing small DevOps teams for large amounts of engineers. Sometimes you can have as few as 3 to 5 DevOps engineers to hundreds of developers. Sometimes those teams are a little bit bigger. Sometimes they can be very small. But in all cases, the DevOps team is usually a very small, focused group of people who support the infrastructure for the entire development and engineering organization. And on top of that, these DevOps engineers this is where the cost goes. Cost is very rarely laid on the at the table of the engineers themselves. It's laid at the DevOps engineer, the person who runs the production infrastructure, the person who's making the decision of what type of infrastructure is going to support the applications. And of course, there's a labor overhead. Infrastructure management is complex and time consuming. So if you have a small team of DevOps, how much of their time is dedicated to massaging this infrastructure so it's the correct thing that engineers need? How much of their day is spent making sure that they have the right instances at the right time and the right scale, and putting everything together so this really wide breadth of applications that are containers, when they're deployed to Kubernetes, who's making sure that all of those containers have the right infrastructure underneath? Because not all CPUs are created equal, not all storage is created equal, and even not all network is created equal when you go to the cloud. And when you start mix and matching containers and all these different applications that you can deploy to a single cluster, how are you making sure that underlying infrastructure is actually giving those applications the means to run properly? So all of these are problems in day 2 for DevOps engineers. These are real things that they need to deal with on a daily basis. And we're going to dive into that a little bit further. So let's get into it. The 3 key questions for DevOps on day 2. First, how do I choose the right infrastructure for applications? So we just spoke about this a little bit, but let's dive into it a little bit further. So Kubernetes scales pods, but infrastructure scaling, again, is either done by a plugin or up to you. You can do it yourself. You can create all the VMs and attach them to Kubernetes. Kubernetes is perfectly fine with that. There are a few plugins you can use for Kubernetes, which will do some rudimentary scaling for you. But at the end of the day, the infrastructure is given to you. Kubernetes scales pods. It does pod and container management very well, but underlying cloud infrastructure is given to the operations teams. So implementing auto-scaling is a best practice, but only 28% of Kubernetes applications are leveraged for auto-scaling capabilities. So Kubernetes has all of these things, and we see it across our customer base too sometimes, is that when people initially come on with a fresh Kubernetes cluster that they've done themselves, is they don't enable all these different features of Kubernetes that are scaling the pods because they don't know exactly how to match that with the infrastructure that's underneath. The cluster autoscaler can be complex and it has some limitations, the default one that comes with Kubernetes, and it gives teams some pause before just turning that on and letting it go, kind of crazy, if you will, in the environment, or just doing whatever the pods tell it to do. There's an operational overhead is fairly high with maintaining all of these node groups and all of these different instance types and everything that pods need. You have to be able to identify what the application needs with the infrastructure that's going to be provided. And then auto-scaling tools today are inherently infrastructure focused. So there's more and more tools coming out to scale pods. But they're not really totally there yet. And if you're scaling pods and you run out of infrastructure, you have a problem. So you have new technology that's geared around pod scaling, and you have some older technology that's geared around infrastructure and VM scaling, and you still need a good way to put these together. So what happens a lot is you see over provisioning. You see DevOps teams, in the spirit of meeting all the SLOs and meeting the uptime requirements of applications, over provisioning clusters. And this is not great because it goes against one of the pillars that we talked about at the top of the top slide, which is FinOps. And FinOps kind of takes a hit here when you over provision clusters just to make sure you have enough capacity for all of these containers to run in the cloud. And last but not least, another point on the FinOps is you can use services like AWS Fargate, and they are quote unquote serverless where you don't have to manage, but you pay for that. You will pay the cloud provider. It'll be a lot more expensive to run on a system like that than to run on a Kubernetes cluster that you control, or even something where you just pay for the management nodes like an EKS or an AKS and manage the infrastructure yourself. So I talked about this a little bit, and we talked about, you're scaling these containers. There's infrastructure underneath they need to land on. So what does that actually look like? And we bring the idea of a Tetris game, because that's what you're playing. Your engineers are creating containers. They're throwing it out into the Kubernetes cluster in a way, and they're saying, go run. Now, the Kubernetes cluster has to look at the infrastructure underneath and say, okay, how am I going to run these applications? And so this game happens where pods are being deployed out into the infrastructure, and they need to find empty space. And, they need to find the empty space. So what happens is, you can see here on the right, there's a pending pod with a certain amount of CPU and memory, and it has to find a place inside the infrastructure to run. Now, that requirement has to happen on a single server. So if you're manually scaling servers, you can run into a situation where this pod can't be deployed because there's not enough CPU and memory on any given server in the cluster, even though there's enough free, right? In total amount in your cluster, there's enough resources free for this pod to run, but it can't because the resources aren't in the right place at the right time. And now that job's pending. And that's not good because containers that aren't running aren't doing business. So what you need to think about with Kubernetes and the infrastructure that's underneath is container-driven auto-scaling. you need to have infrastructure that's going to meet the demands of the containers that are being deployed. So capacity needs to be based on the containers and not some, you can't separate the decisions. You can't say we're going to scale a certain type of VM underneath my Kubernetes cluster. We're going to deploy any type of pods to that, and then it's magically going to work and be efficient. That's not going to be the case. If you have a heterogeneous selection of pods and workloads that are being deployed to a Kubernetes cluster, you also need a heterogeneous scaling solution for the VMs that are underneath. So you need to have a solution where spare capacity is automatically maintained. You're able to handle bursts of containers. You understand when containers are scheduled to the cluster, that it's going to be able to schedule this work, run the work, and scale up and down appropriately as applications scale up and down and as new applications are deployed. So 2, how do I improve this resource utilization? So we just talked about, this kind of disconnect between containers and infrastructure. So how do I make this happy? How do I not over provision everything just so everything can run? And how do I look at my infrastructure and say, hey, I need to right size this? Like I can't just have my VM scaling in one way and my pod scaling in another way. I need to put this all together. So there's a few different things that go into over provisioning, right? The first is pods themselves. Many engineers, developers will ask for more resources than they actually need. This is not a new phenomenon. This is something that's been happening since the dawn of engineering time. How much CPU and memory do you need? Usually the ask is much more than is actually needed. Now, what happens when a pod gets deployed to a Kubernetes cluster when it's asking for too much CPU and too much memory is that the scheduler is actually allocating too much, and then your infrastructure is allocated too much, and then your costs are too much. So the first thing you want to do is you want to make sure that your pods are asking for the right CPU and memory, because those requests to the Kubernetes scheduler are real requests that result in costs. And you have to make sure that those are aligned. So as you're deploying pods to your cluster, you need to make sure that they're right sized for the memory and CPU that application actually is going to need when running in production. So the DevOps teams need to have a good understanding of the container needs. They need to understand over time what containers normally use, how much CPU, what's the profiling of this application over time. And on each new release of that application, are we making decisions that are more efficient for that pod definition? Are we ensuring that we're only asking for what's needed out of Kubernetes so we don't over provision on infrastructure? Because even if you're matching pods to VMs and you're doing that very well, if you're asking for too much resources in your pod, you're still over provisioning VMs, even though it might look great. You might be, oh, I'm bin packed at 90%, but you still could be wasting a lot of those CPU resources by over provisioning the pods when you deploy. Another thing that you want to watch out for is over bin packing and getting too close to that 100% line. Auto scaling applications, dynamic applications in the cloud need to be able to burst and come back down in many cases. And if you have an application that's like this, an application that needs to spike suddenly and then come back, you also need to ensure that you're over provisioning intelligently. And what I mean by that is not all over provisioning is bad. If you have applications that scale, you need to make sure that when that happens, infrastructure is available for that to happen. And you need to do it in a smart way. You don't want to just blindly over provision for all applications. You're wasting money. You want to intelligently over provision so that applications that do scale have enough capacity to scale before new infrastructure needs to be turned on and connected to the Kubernetes cluster. So you need to be thinking about all these different things. It's about bin packing effectively, but not only bin packing effectively, thinking about how that bin packing also works with the scaling of your applications to ensure that any over provisioning you do have is benefiting you by keeping your application and your SLOs as high as possible. So let's dive into container right sizing and bin packing a little bit more. There's a lot of constructs that go into this. There's the instance and VM size that's underneath. There's the type of VM. The pricing and allocation is determined by those container requirements. So when you deploy a container, you need to be able to know what that container needs, what type of instance it should fall on, what type of pricing model, and what type of runtime model that it needs. And when I say runtime model, we're gonna later in this slide, we're gonna talk about the differences between spot instances and on-demand instances and reserved instances, but I'm gonna hold off on that for a little bit. You have to constantly monitor and analyze the container utilization because you must modify these pod requests over time. It's not good enough to deploy a container, see that it's green, and then just let it run. You have to continuously understand what that container is doing and right size it over time, or all you've done is added another layer of inefficiency to your deployment stack. Because again, remember, if your container is not configured efficiently, your infrastructure is not going to be configured efficiently, and then you're going to be paying way too much for the cost of that application. So you need to think about all these things to intelligently allocate the pods to nodes for the highest utilization. So if you look at the graph on the right, you have a node, you have all these different pods in this Tetris game that fit onto this node. You have many different nodes which might serve different purposes. You might have different CPUs. Your application might need a GPU. You might need a certain generation of a VM that's different than a generation of CPU or processor for another application. You might need networking requirements for a certain pod that are different than networking requirements of another pod. All of this can be done within a single Kubernetes cluster. But someone has to manage how all of that works at the end of the day, and you need to take this into consideration on day 2. So we've talked about it a lot, and I've mentioned it a few times. How do you keep cloud cost efficient, but also reliable, right? So we talked about both things. If you're overly bin packed in one way, you're not scaling in another way, you're going to miss out on your SLO. If you're over provisioned, you're going to hit your SLOs, but you're going to be overspending. There's got to be a magic middle ground somewhere. So on the left, I mentioned before heterogeneous, that's on the right, but let's focus on the left. Homogeneous scaling. This is what a lot of people do in day 0 and day 1. They pick a single instance type, they're testing a configuration for a single application, they scale up, and they scale down. And what happens is you're usually over provisioning just to make sure that the application runs correctly. Now, every time you're going above that application needs line, you're paying more money than you actually have to pay. Over on the right-hand side, we show what a heterogeneous model looks like. So this is where the application is defining what type of infrastructure it needs. And then what you're doing as a team is you're bringing the infrastructure and VMs that the application actually wants. And this doesn't have to be a single VM type. It doesn't just have to be, the best VM type with the best CPU and the best networking just to ensure things work. You can bring a whole different set of VMs and infrastructure configuration to the cluster. So all of the pods can get as close to that scaling line as possible at any given time to ensure that the applications are running correctly, your SLOs are being met, and your cost point is as low as it possibly can be. And this is where I get into the different purchasing models of the cloud. So I mentioned this before, and every cloud you go to, whether it's AWS, Google, or Azure, there's 3 different cost models that you can bring compute infrastructure to your Kubernetes cluster. The first is on demand. It's list price. It's what you see when you go to the website. It says it's going to cost $1 an hour for you to run a certain instance type. You load it up and you pay $1 an hour, you get that instance type, and you get some sort of SLA with that, usually a 4.9 SLA. Now, that scales up and scales down. It works. It has an SLA attached to it. It's the most expensive model that you will pay. It's the most expensive way to pay for cloud, but it works. It's good for day 0. It's even good for day 1. Now, when you get past day 1 and you start getting to scale, you're going to realize that on-demand is actually really expensive and is probably more expensive than even what you were doing before as you scale up and down. So you're like, okay, I need a different cost model. One of the first places people go are reserved instances. Now, reserved instances are an agreement between you and the cloud provider where you say, you know what, I've been running these on-demand instances for a long time. I'm going to continue to run them, probably 365 days a year. So if I commit to you to run this instance for 365 days, will you give me a cheaper price? And the cloud provider goes, you know what, fine. If you pay me every single hour for every hour for an entire year, I'll give you a 40 to 50% discount on that VM. So it's more affordable, but you're committed to run it. You have to pay that cost every single hour of the year, whether you're running the VM or not. So you better be sure that you're running those VMs, and anything you buy reserve capacity for, you want to run those VMs as often as possible, because if you're not running it, you're paying the cloud provider for it anyway. So it's a good way to save money, but you have to be really, really sure about the number of VMs that you're going to run. And then finally, you have spot instances. And of course, we love spot instances. We think they're the best way to run any application. Now, it's a little bit different than on-demand and reserved. So spot instances are sold on what's called a spot market. And in AWS, they're called spot instances. In Microsoft, they're called spot VMs. On Google, they're called preemptible VMs. Now, this is the cheapest solution. This is great. Spot instances you can get for 10 cents on the dollar. That's right, 90% off list. So you can save a ton of money. Now, what's going to happen is they're going to take away the SLA of that instance, which means the cloud provider at any given time can ask for that instance back. If they need more capacity for on-demand workloads, if more people come in and start using up what's called a capacity pool, the cloud provider can take those instances back, and then you got to go find another instance within 2 minutes or so to keep your application up and running again. So by default, spot instances are usually used for mostly batch workloads, but it is possible to use these spot instances in a good way if you understand all the spot markets, if you understand where markets are going and how they stay available. You can run production grade applications on top of spot instances if you know what you're doing. And if you can do that, you can turn that 40, 50% savings that you see with reserve capacity into that 90% savings that I talked about. And that is, when you combine that with bin packing and you combine that with everything else, you really start seeing some value. So let's dive into it a little bit further. So first, I already talked about it. It was on the previous slide. It's one of the riskiest solutions because the provider does not offer an SLA on spot instances. You can allocate it and it can be taken from you at any time. Now, some of the cloud providers have a warning, but the warning is not very long in front of when the spot instance will be removed. And sometimes the spot instance can just be removed by the cloud provider. So it can be as little as a 30-second warning before termination that you would know that you need a new instance to replace a spot instance. Usually these instances are terminated based on capacity and availability for a configured region or an availability zone. Most of the time, spot markets are defined by an availability zone itself. So think a single data center within an entire cloud provider. Knowing what's going on in these different data centers and being able to run on spot markets of different types will keep you highly available. So the availability capacity is based on the region you're running in, the type of VM that you're running in, and the time of day. So there's a lot of things to keep into account when you're running on spot instances. But if you can put all of this together, if you can take all these metrics and put them together and you can understand how to run spot instances, again, this is the best of all worlds. If you can bin pack properly, and then you can run your infrastructure cost effectively, now you have that magic solution where you're matching the optimization of your application from the pods to the VMs to also how you're paying for those VMs and how you're orchestrating those VMs in your Kubernetes cluster. So this is where we get to what we call hands-free infrastructure for containers. So we've talked about a lot of different things that you need to be aware of in your Kubernetes journey. And when you get to day 2, where you have this very large Kubernetes cluster and how you're going to run it efficiently, what are you going to be thinking about? What responsibilities do you want to take on yourself? What do you have to do to make this work? Now, I'm biased. Spot by NetApp makes Ocean, which I believe is the best tool out there for this. But I'm going to talk about what Ocean does. And that's as important as anything else, because this is where, regardless of what you use in the world, this is where you want to get to. It happens to be the features of Ocean. But first, container-driven autoscaling. You want to ensure when pods show up to a cluster that those pods are asking for the infrastructure they need and then that infrastructure is being provided to them. What you don't want are generic pods being deployed to generic infrastructure that will be inefficient at the end of the day, will not scale for you. You want to use labeling, and you want to use the constructs that are available in Kubernetes to define how those workloads need to operate. And then you want to have a system that will give the correct infrastructure to that, whether you're using node groups. In Ocean, we call them virtual node groups. You need to have that mesh of options available for those containers and those workloads when they're deployed. And then you want to make sure that you're maximizing the resource utilization, either by CPU, memory, or both. You want to make sure that those pods are landing on the correct VMs in the correct way so that you're using as much resources in the cluster as possible. Remember the Tetris game. If pods don't line up correctly, it's just going to go to a new VM. And if pods keep going to a new VM because they can't be combined correctly on the same VM, you're slowly becoming more and more or less and less efficient over time because you're wasting more and more compute power on every VM that you can't bin pack effectively. You want to be able to bring your own Kubernetes control plane. So whether you're using straight up Kubernetes, EKS, AKS, GKE, anything your heart desires, Ocean can work with. You want to make sure your scaling solution can work with generic Kubernetes masters. That means that the solution that you have is as Kubernetes native as possible, that it works with the scheduler, and no matter what scheduler flavor you have across any of the cloud providers, it works. Ocean does this. Ocean can work with homegrown Kubernetes. It can work with GKE, AKS, EKS, it doesn't matter. It works with all of them, understands all the cloud providers' APIs. And then, of course, you want to get to a point where you're saving up to 90% off your infrastructure costs. And Ocean automatically looks at the pods. And any solution you have should do this. It should look at the pods and then decide, does it need a spot instance? Does it need an on-demand instance? Does it need a reserved instance? Am I using all of my reserved capacity that I have available to me so I'm not wasting money? Is my reserve capacity is used up? How aggressive am I being in the spot market? And then when I'm in the spot market, what tools do I have to run the spot market effectively? And this is where Ocean really shines. Because with Ocean, which is built on Elastic Group, another Spot by NetApp product, we have full visibility into how markets are running across the clouds. We have aggregated statistics on how all of the spot markets are working, and it's about getting in front of those spot markets. It's about being able to provision infrastructure before infrastructure goes away. That's the trick with the spot market, is to understand when to bring VMs into the cluster before any kind of reclamation or any pullback of VMs happen. And this is the power and the magic of a platform like Ocean, which will be able to do that. It'll be able to understand bin packing. It'll be able to understand how to make pods efficient in and of themselves. And then it understands the spot market and understands the scale and the scope and the breadth of all of these markets. So it can bring the right infrastructure at the right time. And it does all of this automatically by hitting a button. So DevOps teams, if you use a product like Ocean, you don't have to worry about all the things that I just talked about. And then when you're using it, you're going to get full cost management and showback of everything that you're doing. And then every time an application gets deployed, you can turn on automatic right sizing for your pods. So now you're monitoring instead of managing. And this is a big shift. Right? If every day you're coming in and your DevOps teams are managing infrastructure, and they can change that from managing infrastructure to monitoring infrastructure and making sure that infrastructure is just acting the way it's supposed to, you free up precious DevOps cycles to do other things during the day. And that's what Ocean brings. It brings all the things I just talked about automatically. You don't have to do anything. Ocean does all of that work. And then it brings all the visualization and all the charts and everything that you need to see that applications are running effectively and that you're right-sized effectively. And then it becomes a monitoring operation. and you can use those extra cycles on your DevOps team to go do other things, to go do business critical things that'll help generate more revenue for your company. So that brings us to the end of the presentation today. I hope everybody had a good lesson on what day 2 Kubernetes is. I think we went over all the major things you need to be concerned about when you're running production grade applications in containers, on Kubernetes, in the cloud, at scale. Ocean is a great product to give a try. If you're on day 2, our customers are able to free up a lot of DevOps cycles by turning on Ocean. So I highly recommend it. It really addresses all of those day 2 pain points that I talked about before. And I just want to say that I look forward to all the questions that are coming, and I hope everybody is looking forward to a great KubeCon. So thank you very much.